This is the energy of the ball toss lab.
Computers can be off. When they're off, you should press this button, the on button. Now you want to attach the sensor.
On right now.
Make sure to put in the first port by putting yellow in the first one and black in the second. Now we want to use Data Studio to set up for the lab. Open Data Studio. Create experiment. We're using the same motion sensor as previous labs, so of course we want to hook up the motion sensor. Once we've done that, we'll want to pull up a graph. The velocity one, because later what you'll be doing is swapping between velocity and acceleration using regressions. So let's pull this up. We're also going to add just the position graph. So we'll go again to graph, double click, pick position. Then to display this well, we're going to go to window and then tile and get rid of this really useful tip.
Now you have to get the mass of the ball. The first step is to plug in the scale. Now, these scales work a lot like computers. They have an on button, which you should press in order to get the weight to start at 0. Now that the weight says 0, we put the ball on here and read the scale. Now it's time for the actual lab. What we have to do is throw up the ball in front of the motion sensor. So use both hands for this, click start, then throw up the ball and record your data.
Your data should look something like this. A couple of tips to make it accurate is to make sure your hands aren't above the sensor. So use both hands but kind of hold it at the side of the ball. And second, you want to start about half a meter above the sensor so it can read it accurately. So now you want to create two different functions from the graphs you have. One to calculate kinetic energy, which is 1/2 mv squared using the velocity graph. And the other is potential energy, mgh, using the position graph. So we'll first make the function here. What you do is you click on calculate and it'll pull up this window. Now you input it, so 0.5 times m times, now you put x as just a generic variable, and then square that to correspond with that equation. The important part though of this tool is you need to now specify what all of these are. So we'll go here, they say define variable x. X matches with the data measurement, being our velocity curve. Define variable m is going to be our constant, being, of course, the mass we got. So for us, we got 586 grams, and we inputted it like so. Now you want to press accept, and then new, creating the second function for potential energy. So again, it's going to be m times g, and again, times x. X we're going to define, this time, again, a data measurement, but this time it's going to be our position. M is going to be, again, our mass, a constant of 586. And G is, again, the gravitational constant. So it will be 9.8. And then we want to accept this, and we're pretty much done with the calculator then. So now what you want to do is you want to graph those. So we'll double-click graph, and now see you have your functions pulled up right here. So we'll pull up this function, and we'll pull up the second function. And as you'll note, they should actually correspond. So what we mean by that is the velocity, because you're squaring. This area should then pop up over here, just as this one's mimicked all over here. Same thing goes for position. When you move this down, you'll see they match, because you're just trying to multiply by pure position, and thus you'll get a similar shape with both curves.
Now that you're done with the lab, do the analysis questions and be sure to show work. Remember, we've hidden the Millennium Falcon in this video somewhere. Try to find it.